An additional addition. Hmm. How to solve that problem? Yep, suppose we have this. And the constructor of C1 does yeah, whatever, new L4. L4 definitely not a member of this class, it just got created. So I think L4 should be pop up in the root graph. I think I'm only using subgraphs for classes, right? So something in the subgraph is a member of or a base class of. This is not a member of C1 or anything, and it's also not a base class of, so it's just a node by itself. It should be added to the root graph. But at this moment we still have S2 open. Is there an easy way to detect that? I mean, the creation of the actual members are in between S1 and SE. Let's do the indentation here. I need to be able to make a distinction between the constructor of C1 and the creation of other members of S2. And then there is the question of creation of in containers. I mean, what if, say, we have a vector the vector of label nodes. Well, stuff derives from label nodes, but whatever. So it's some vector, and then in the constructor, I'm doing a pushback. Why not push back the new L4? I'll be a level node pointer, however. But yeah, I mean, and plays back, and we solved it. So this is not a label node, but something derives from a label node, which then takes a pointer to something. So this should pop up in the root graph. But what about this object here? That is part of a vector that is a member of C1. Is every element of V a member of C1? I don't think so. V is a member of. But V is not really a pointer. Or on the other hand, the standard vector is kind of like a pointer to heap allocated memory. So I kind of already decided to put vectors outside the class. So we would have an edge that points from C1 to a node outside of this C1 box, which then contains the vector. So the vector in itself is its own subgraph, or maybe table node. It's a single node that exists of HTML. It has an HTML label, table encoded in it for each element. I guess I should add something here. Do we know that we are in the constructor? We also have to add it's more difficult even. Suppose we use a default constructor. This is a default constructor. Suppose we use this. Well, that is exactly the same as doing this. Anyway, then it doesn't matter what I add here. This will be filled with stuff constructed before even we get SE. So that really totally looks like all these elements, all these three elements that are added to the vector. They will be added to S1. So we open S1 and then we add L1 and we add L2 and then we add three elements, three more level nodes. Ugh. So if you look at it like that, then it's just simply not allowed. To have a bare vector that contains level nodes, must wrap the vector itself into something. It gets more and more intrusive. More and more intrusive. Which is not nice at all. Really want it just to be automatic. Automatic. What I can do is say pass C1 to S1, and then we know what the size of C1 is, and we know what the this pointer of C1 is, because it would be equal to the this pointer of S1. And then every time something is constructed, we can look if this pointer falls inside that region. So, for example, the moment L1 is constructed, we not only know that S1 is open, but also that this point of L1 falls in the region that we just opened, as it were. So this whole memory block. Don't even need that anymore then. And then if you create a label node inside a vector, it's going to say, yeah, well, that's nice, but it does not belong to this object C1 because it's allocated on the heap instead of in the memory area that is reserved for C1. I'm not sure what I want to do though with those vector elements. The only way that's ever going to work is when you detect automatically that a vector is created. But even then, you need to know what vector something is constructed for or in, or what is this going to be part of. I think this way we'll just have 3 level nodes and nobody knows that they are in a vector at all. Maybe it's not even too bad. But how do I want to display a vector? I mean, I wrote my own vectors, well, sort of, that have a special type for the index that you use for it. So my plan was to show those inside their own subgraph and then put all vectors and DQs with the same index type in that subgraph. But even then, say this is the subgraph belonging to vectors with index, well, this is an array, but okay, let's say v index, some index type. And suppose this here is even one of my own vectors, which uses a v index as an index type instead of int. And let's say that magically this causes a subgraph to be added to the root graph with the label v index. And then the very creation of this thing should make a table node in it. And we need an edge from C1 to that table node then, so like here. So this would be v underscore, I guess. So this is C1 and this is v. And that points to something that represents a vector. I mean, and then at least I know how I want it to be displayed. But you still have the same problem that at this point it's just a label node is constructed. Or whatever thing that is. It doesn't know that it's part of a vector. So maybe it's not a problem really that say we start creating them and then just dump them in the root graph. I mean, I'm not displaying the graph at that moment, but they are added to the root graph. And then here we say do something, causing them to be removed from the root graph and being put at the right place. say we do here. And then at this moment we know that we are one in the constructor and two that v is a vector. Because you pass it as a parameter, so now we know exactly what type is. And then at the moment that this is being done, we have to run through all the elements in the vector and remove them again from the root. I think we can add them later. It's not even necessary to add them anywhere at the moment. I mean, here's another one that's being added. And then just before drawing the graph, we can run over all the elements of those vectors and then generate a label. I thought it would be simple, but this whole project turns out to be basically impossible, so maybe I should not do it. I guess I should concentrate. I should go back to my Vulkan engine, concentrate just on the bug that what we have. I was writing this to as a tool to create a graph that would give me an overview of what happens in the pipeline factory, but it's just way too difficult. I don't think I would ever get this to work, or certainly not within the time that I could normally fix that bug anyway. Which is, it's too bad though. It would be a really, 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 really nice tool to have. Yeah, I don't know. Apart from the vectors, it seems to work, more or less. Can I think of something else that would be a problem? Well, this is a problem. Oh no, I could detect, I can use this and then just detect if newly created objects are within this range. So it's an idea. Well, I think I want to implement it, just to see. I have several problems then though, however. I already wrote a lot of code, and I extremely hated to throw away code. I would rather start from scratch actually, because then I just, otherwise I have all heaps of code laying around that I don't know if I still need it, or if it is usable, or that it should be completely changed. Thank God I put a lot of the code in its own namespace. This is even more code, but kind of unrelated, except that I'm not sure if this code is correct, actually. It looked correct. It looked even finished. So then I started to write this code. There's something wrong with it. Dark. Well, unfortunately, I never used Unreal Engine, so I'm completely clueless. I could learn it. I think it's just a matter of installing and starting to read and, you know, begin and don't stop until you're an expert. Yeah, the structure of this dot namespace is that I have data objects that don't have their own file, but we have edge data and graph data and node data and table node data, and everything has its own data. And those data objects are allocated on the heap and they don't move in memory. So I can use pointers to it. And then we have the objects that do not have data. So look at the node. Yeah, it's pretty empty here, but okay, it's derived from something. And then we have this one, which is a wrapper around a smart pointer to the data. So the graph item here is just a boost intrusive pointer that points to that data. This is the only element that it has, the only member that it has, I mean. Meaning that it's super lightweight to make copies of graph item or move it around. And in the meantime, it just is a pointer, or you have several pointers to the same thing, and this is the data is never moved in memory, so that pointer is always valid. And if you destruct all graph items that point to that object, then it's automatically deleted as a bonus. So we have a node, and we have also an edge, which then of course also is a graph item. But there's not a using edges graph item edge data. It actually has a constructor and a function that allows you to set a from and a to port and get it. Accesses for that as well. Those ports are then, of course, not stored in the edge, but in the edge data, right? Yeah, this is where they are stored. So this from and to point where the edge begins and ends are not part of graph item data, because that's a base class that is also used for nodes, and this is specific for an edge. Likewise, the other stuff has sometimes, well, a lot of extra. For example, the graph. The graph data also has a boolean. If it is strict or concentrate, it has attribute lists. Those are the default attribute lists for all nodes and all edges, unless you override that with in the node or the edge itself. And of course, it has links to other graphs, subgraphs, and to all the nodes in the graph and all the edges that are part of the graph, and then my special nodes table node. Anyway, now I start to think that maybe this is not the right design. I think I argued before that it is necessary to have something that is not moving in memory, because it's necessary to have a pointer. How was that reasoning? Let's say a user class is derived from something that makes it a node in the graph. So let's say user class A is derived from node, and now it's a node. But yeah, really, my graph must know about all the nodes. So either now the graph has to point to that base class, the node base class of the user class. And that's certainly a no-no, because the user clauses go all over the place, of course. They could be moved or part of a vector that gets reallocated and stuff. You could never point to a user class. So alternative is that the node itself just has a unique ID, and the graph just stores that unique ID. But yeah, even then, I mean, in the end, you just want to access the base class, right? So you need a pointer, and the thing is being moved around. So it just doesn't work. It works as long as you just want to use dot of graph_vis and create a graph, draw the graph. But if you want to do anything more sophisticated, which I'm like we're talking about in the beginning in the README, and what I'm doing in this directory, then you need a pointer to that base class. Here's another node, and that node is really tracking, the object that is derived from it. And you definitely do need a pointer to it. And then I ended up with implementing a node tracker just to get that working. And yeah, then I have to do that for everything. So I might as well make that part of the dot itself. So the idea of the node tracker is that, or any base class tracker for that matter, is that it does have a pointer to the base class, but itself it doesn't move in memory. So the node tracker is fixed somewhere, allocated on the heap, doesn't move. And say my graph can point to it, and the node tracker itself has a pointer to the node, which might move in memory. But at least the graph can just point to this, and then get the node pointer if it wants to. And then if the node is being moved in memory, then it has to call this. So you can see that happen. Just go to node. So this get tracker. Yes, tracker. So the node has a shared pointer to the tracker as well. And if you move the node, that would be this move constructor here. Then it moves to the tracker. and then it calls a set node with the new place where we moved it to on that tracker. So the tracker is updated here because the base class that we derived the user class from was moved in memory. Now, of course, if you make a copy, then something likewise happens. But in that case, you really make a copy, so we just make a new tracker. So here's the copy constructor that creates a new tracker that points to the current object, the new object. That's basically the same thing as we do when you just create a node period. I think I should move the node tracker pattern ID or whatever to the dot namespace. So I don't need to be bothered by it in this namespace. Do I have something that compiles? Yay. In fact, I think I committed everything. Well, almost. What is my diff now? Oh, we just added a lot of debug outputs. Which was to understand the bug because it doesn't work, and it doesn't work because the whole design is wrong. I think I can get rid of all of this. How do we do that? Let me go to the base here. Wow, is that nonsensical? Pretty much. Yeah, I just want to discard everything, yeah? So that is restore dot. No. Okay, so do I still need my node object if I have a node tracker? It's something totally different, isn't it? No tracker. Something different. It is something different. Let me see. So here, no data is a graph item, which doesn't move in memory. It's actually graph item data, but well. And I want to introduce a node tracker, which also doesn't move in memory. So I suppose maybe those two can be combined then. No, they cannot. Or can they? There they can. The big difference is that my other node that I derive from has a one-on-one relationship with the node tracker, as well as a one-on-one relationship with the graph item. So the label node or whatever is visible, and that would be this node. It's so confusing sometimes that I call a node here and I call a node there, and they're different things. Let's say I call it the dot node. This one is in a namespace dot, so call this dot node. Now we have dot node, we have dot node data, and we have node, and we have node tracker. Yep. And the relationship is as follows. The dot node data does not move in memory and is the representation of a label node in the graph, in the dot graph. I mean, a graph only has nodes. The whole whatever other things we have is not even real. Except you can treat graphs as subgraphs. But yeah, it's more like an artifact, you know, a box around a number of nodes. So my dot node data represents a node. I'll just call it a node in the graph. And the dot node is a pointer to it, which you can copy and move. It doesn't duplicate the node if you copy it. And the dot graph has pointers. No, I'm not sure. I mean dot graph data to begin with. It has this graph item of stuff. Say the nodes are stored like graph items. And the graph items are intrusive pointers. So yeah, we have that's a wrong word, isn't it? It should be a graph item pointer, and then just to rename graph item data into graph item. Rename graph item to graph item pointer. That would make things a better readable, I think. Daniel, yeah, I'm using no IDE. Data. Why would I even use a pointer? What else can I use? Need to access it. But why am I using an intrusive pointer? Why not a unique pointer? I like that idea. If you use a unique pointer, it shows that there is a one-on-one relationship between the graph and the node. I think the reason I used an intrusive pointer, aka a shared pointer, because I had a feeling that maybe the node shouldn't have any awareness of the graph. Just a node is a node, floats around in its own space, doesn't know anything about graphs. And then externally, a graph can decide, hey, I see that node floating there. Looks tasty, let's use it. There's a node in my graph. And then it's basically that two different graphs could decide to use the same node. And then you need a shared pointer. But yeah, that's kind of confusing. It's maybe an unnecessary flexibility. Plus, then it turns out that in the end it just didn't work. At least when I went outside the dot namespace, my nodes totally need to know what graph they belong to. Totally. This is more like a podcast than coding. You could have gone for a walk listening to me. Yeah. Yeah, Brex, I'm still stuck, man. But I don't know. Intrusive pointer. Do I want to limit myself to a one-on-one relationship between a graph and a node? Let me think about that. Shy, have you taken your medicine lately? It's really not a good idea. If you're on psychotics, to stop with that. Yeah, you need to keep taking them, man. Anyway, I'm stuck. I don't know what to do there. I think I should rework this a little bit, but how? You should be studying. Why are you not studying, Brex? Well, I usually stop my stream when I want to walk away from the PC. I need to move a little bit every now and then in life. Can't just sit here. Nah, I'm not convinced that it is a bot. I think it's just someone really confused, and it would be cruel to kick him. Well, I'll play a game of chess because Brex doesn't let me leave. Because I can't code anymore. I need to get to 2000 again. Rating is way too low. Free pawn. Looks like a free pawn. Okay, so I have to play this. Well, I need to develop. So I put my bishop here, that would be nice, but then this bishop comes there. And then I have to let go of this bishop. Could go here, I guess. Take, double pawn. Not nice, even though I could keep my pawn. I could play my knight out. It's kind of stuck here though. Well, where do I want the knight to go? There, that would be nice. So then my queen has to move anyway. Okay, so I could do, I guess I could do this, but then I block my bishop and then my rook is not defended. They probably put the rook there, threaten to attack my queen. Even if I go one back, they would just take here and I'm dead. So it would be nice to defend the rook, or maybe you can just start with playing this immediately. It's probably best. I could put my bishop here, that blocks that attack. That seems like a good move. Now the bishop comes here. Yeah, oh yeah, bishop here and my queen is kind of trapped. I can still go in the corner, but nothing to be very happy about. Oh man, it's really bad. No development at all. Do I have time to play my bishop here? I just go in the corner. Maybe. I'll have to try, I guess. I'll just have to try. There! Oh, now the bishop wants to go here. Well, now I can just go here. Plus, there is no bishop going here because I just take it. Rook there. Well, at least then I cannot move my queen. I want my move to I want to move my queen here. Exchange the queens, or threaten to do that anyway. Oh boy. I don't believe this. Am I dead? I'm pretty much dead. Plus I don't have time left. No time left. Mate, yeah. Oh well, that was strong of this guy. I really want to see this in the computer. Where I went wrong. This is theory. Yeah. I thought it was a free pawn, but he gets a very strong attack. Anyway, taking it seems to be okay. Again, taking is okay. I'm playing like a computer, as it were. And that guy too. Not well playable, apparently. So far, Stockwiz moves. Grandmaster. Oops, that was not good. What did I do? I took the knight. Yeah, I didn't see it. I thought that knight might be strong. Now minus a half while being a pawn up. Ooh, okay. He is not using a computer. Gives me the point back. And I give the point back again. Oh, this was a nice opportunity to develop my bishop. Yes, definitely. I completely missed this. I wanted to develop my pieces, but if I went there, I would end up with a double pawn. At least after this move. Now I can no longer move my bishop here without getting that double pawn. Still, I would have to do it, but I didn't. Minus 1.3, minus 1.5. A draw if I... Now I can develop my knight. Don't tell me I didn't. I did. Okay. Rook. Still have to bring out my bishop, but I really did not want to get that double pawn. So instead, I played my pawn up, I think. It's probably very bad. No, minus 1 again. The knight was not good. I should have blocked the pawn immediately. That's a draw again. Again play the bishop. Draw. +1. I blocked the pawn. Now the threat is gone apparently, and I'm just one pawn up. Still +1. Or not. Yeah, this allows him to play the bishop here and there. That was not good. That was definitely not good. I should not have allowed that. So if you play the rook, then you stop that. Yeah. Yeah. Yeah, that doesn't make any sense because he just wants to go there anyway. And it goes downhill from there. -2-ish, -1.5 with the pawn up. Unbelievable. Black has got his attack back, and not a little bit. It looks like you have to give a rook for the bishop or something to survive this, because of the, well, -1.7. That was apparently a good move. Oh, now I'm dead. Really? Why? I should have moved the rook. No, this move made allow black to actually cash in. Although I don't see how. Well, I said that, you know, rook here and then threatens to take my pawn. That's pretty bad. But he didn't do that. -1.5 again. So I have a chance to defend this. Oh, I didn't. Still an attack. Still an attack. A huge attack. The bishop move is also nonsense, apparently. Yes, everything loses. Now I can sacrifice the queen. I should have seen that. Wait, is that the best move? That is even the best move. You can still sacrifice the queen, but apparently this is even stronger. Mate in 6. 1 and mate in 2. It's pretty amazing that apparently this position is undefendable. So especially this one. How can defend against this? What is the threat anyway? because the threat is taking here. Suppose you do this, yeah, the threat is taking here. Check, if I go away, then it's made in 2. 1, 2. If I don't go away, or I put something in between, it's also made in 2. You just take it and then I have to give my queen. And the only other reasonable option is to take there, and then we get check and check and mate. Don't know, still not mate. Let's go there. Mate in 12. Yeah, obvious, of course. Mate in 12. How? Okay, put the queen there instead of the rook. The king can go nowhere. Let's put the rook there. Oh, that's made in 1. Yeah, that's the reason. That's why you can't do this. Oh yeah, no, really. This is extremely hard to see, I think, but okay. So the king can be chased all the way here, and then we block the bishop and this deadly attack. A mate net. I want to see the mate in 12. It's still like extremely much. Has to take with the bishop, and then I can take with the rook. I have another check. Check. It's just the long way. Funny. Can't allow that. But yeah, if you put if you try to defend that, then you get oh, what do you get then? Double attack on it. Doesn't even take it. Double attack on the rook. To defend that as well, apparently. Oh, and then it's a pin on the queen. So now we can take here. Yeah, let's do a check in between. Okay, why not take here and do another check in between? Why is this a bad move? So half a point worse. Yeah. So nobody gets it, but that was that's way too difficult. Oops. So if you defend g3 like this, then the best move for black is to go there. Every normal puzzle would have taken this, and then then it's better for white. Wow. That bishop is strong. No way we're gonna give away that bishop for that rook. That's an interesting puzzle, man, here. What's the best move for black? Can make this a puzzle. Black plays and wins. Yeah, unfortunately that it's not that bad. I think that's the only good move. Okay, let's play another one. I keep losing, right? Lower and lower that rating. I even have to play against 1700 players now. Yeah. Every normal person would have castled. Oh, is that correct? So now I can go there to defend the mate. Put my bishop here, or better even there. And now I put my bishop here, threaten mate here, and push the pawn. I can just take it now because the knight moved. But he can put the knight there to defend against the mate. I can go here, I think. Let's go here first. No idea why I did that. Force my opponent to develop the queen. Is that right? I guess now the pawn can come forward. No, they cannot. So now there's no knight anymore that can defend d2. And the pawn forward is losing the pawn. Oh, the queen defends g2. For now. Yeah, I could go here maybe. Point is a bit too good defended. If I take back here, I lose my bishop. Not good. Oh, that was stupid. But well, what can you do? Oh, is that correct? Is that possible? And the queen just goes to the main diagonal here. Well, otherwise I threatening mate here on f3. So the queen goes there or there. Or it doesn't. Impressively Press move. No, I'm going to have to take it, I think. Two pawns for a knight, but this pawn is pretty far. But yeah, nah, not really, right? And no time on the clock. I'm afraid I'm going to lose again. Oh, okay, let's get it. Let's take it. Right. Pretty annoying. That looks like mate. Truth is very annoying. Yay, I got a draw. Hap, what move was that? Queen fork with bishop. War, when? Tell me. We're already completely winning here though. Minus a lot. So which move? You can look here and then tell me which move it is. Seems I have been winning here all the time. Taking it was a good move. And now I should take the pawn, but I didn't. I castled. The weasel that I am. And now it's minus 6.5. I should just put my bishop one back. You said go back. Minus 6. Take. Queen. Oh, I'm going to threaten what something? I'm threatening, I don't know what I'm threatening there. Probably to go there and then give mate. But this thing just goes there, so what? Still minus 5, good enough. And there I give it away. What should I do? Just still, the queen has to go there and there, apparently. I don't see how this is winning quickly. Oh, queen is not going to h3. He developed a rook. Knight attacks my bishop. Bishop goes back. Queen goes here. Nobody knows why. Really, it's not tactics. It's more +6 strategically or something. Computer never saw a game before with a hole here and no white square bishop. While black does have one. That was not won by black. Super vague. Move 28. So here I should take the pawn. Well, that isn't even such a bad move. Take the pawn, or at least I'll win a pawn. Before where? You said move 28, we're already on 27. Before is smaller, the before is up. Previous moves. You mean after? Later? Now there are no queens anymore, so how can you fork something here? It's when the queen goes to f2. Queen goes to f2, let's move 23. Okay, he goes to f2 and then I was looking for bishop goes there, but this square is defended by the knight and by the bishop and by the rook. There's no way to get through. That was a super bad move. Yeah, I'm totally winning and here I'm losing a piece and the attack. Such a stupid move. He takes it. Well, you can do this. You mean here? Oh yeah, you mentioned the bishop as well. Computer disagrees. If you go here, just put something in between. You don't have anything. Take. No fork. So I think that was the game I took. He takes there, I take here, he takes there. I have a slight, no, I don't have a slight advantage. White has a slight advantage here. And now white has a big advantage. And now he could win a pawn, but I didn't. Now white has a huge advantage. Aha! So he gave it away here. White is winning. Draw. And white is winning again. Uh-oh. I should have attacked the knight, apparently. Yeah. Nobody knows why. +2. +2. +2. +2.5. +2.5. +3. Draw. That's pretty good that I exchanged rooks, right? I mean, I already saw here that it was a, a draw. Well, luck is also part of it, I guess. I do stockfish move though. Oh, that was not a stockfish move. Immediately +5. Losing again. So I should have run there. Why? Oh, he cannot defend it. He cannot defend this pawn. Oh, he could do this. And then I can take it. Yeah, playing the pawn is just stupid. That is losing because now he can cut my king off. But instead he takes, and it's still +7 for white. Boo. So where is he giving it away again? It's not giving it away yet. Still not giving it away. Still not giving it. +8. Oops, that was a losing move. Okay. 10 o'clock. It's my normal time to go offline.